Got it. All right, good. Hey, welcome back. This is Microsoft Virtual Academy. This is Module 6. We're talking about the Jumpstart for C#. This is exam 70483. We were just talking about encryption. We were just talking about, what was the last thing we were talking about?
I have no idea.
I think it was encryption.
Yeah, encryption definitely. What was before that?
Oh, it was all the trust stuff, remember?
Exactly.
Yeah, we had all the data. All right, now we've got some more things to talk about. Darren, what's going on in this module?
So this module, we're going to be talking about splitting assemblies.
All right.
And the relationship to assemblies and projects. And we're also going to start talking about diagnostics and instrumentation.
Okay, brilliant. Well, let's get started.
Let's dive in.
All right, so I guess we can't use terms without defining them, such as predicate, for example. So let's define some of these terms. All right, assembly. Assembly. What is an assembly?
I just wanted to put a shout out to Frank and say, hey, your time is great.
Yeah. Oh, hey, yeah. He is killing it with that. He has got it going on. All right, no, seriously. What is an assembly?
You're welcome, man.
An assembly is a container for a set of resources and types. That's a kind of a sterile way of saying it, but it is totally true. If I were inside Visual Studio and I had my solution open, I would add projects to that solution. In a sense, a solution is a container for projects. Projects, however, is a one-to-one for what an assembly is. It's a container of all my code. It's a container of all my resources. I can have more than one. They can reference each other, and by that, they can talk to each other. There's a lot of value in assemblies to logically or really physically group my code together into a single place. We can have multiple files for an assembly. That's quite a bit of work. The general assembly is just a single file. It's just, I feel like it's like United Nations General Assembly here. Here we are.
Exactly.
So there's more to that.
Like a DLL or an executable? I mean, when you talk about files, what are they?
Well, you know what? The answer is yes. All right. An assembly is whatever your project ends up being. It could be an exe, right? If you're creating some sort of executable, absolutely. Could be a DLL, absolutely. It could be just a library that you reference into your project. It could even be a WinMD, and we'll talk about that as a Windows component that we could create for Windows 8 using Windows Runtime. All right, beautiful. Great. There is a little bit of, it's not really a confusion, Darren, but it is a kind of a balancing act between namespaces and assemblies. So if I were talking about specifically a namespace, or specifically an assembly, that's a file, right? And even though it could be broken, let's just talk about it as a single file.
Yep,
a namespace is logical, where an assembly is physical, a namespace is logical. It could span not just multiple files, multiple assemblies as well. It's just a way of grouping logically all of the code, all of the classes, all of the work that we're doing into one place that might span different files.
Could we also have multiple namespaces within a single assembly?
Right. So just like a namespace can be across assemblies, and a single assembly can hold any number of namespaces, because a namespace is such a simple little container. It has no functionality. Just a grouping is all that it really is. That's awesome.
That was only mildly distracting.
Anyway, so that's what that is.
We have somebody who's suddenly playing music in the back of the room.
No, I think he's watching the video, and it's just he's a handful of seconds behind.
Oh, that's
right?
awesome.
Yeah, that's why it sounded so good. I think it was my voice.
I can't believe that for a moment.
The fidelity was beautiful.
Okay.
All right,
back on target.
Namespaces and assemblies. All right, for sure, an assembly defines a scope. It defines where things can be executed, just like a namespace can define a much larger scope. And so if I'm inside a namespace, often that's a domain, and we can stay inside it. And so that's, if I were trying to pick between a namespace and I was trying to pick between an assembly, more often than not, all of the code you have will end up being in an assembly when it's geared towards a specific platform. It's geared towards having a specific set of, say, logic. I'll create an assembly of type library whenever it's something reused across all of my applications, and I might have an assembly that is like an executable or some sort of UI whenever I'm building the UI.
So give me an example of what you mean by namespaces.
A great example of namespace are the ones that come with the framework, like system, right? System is certainly a namespace that spans many different assemblies. System.file, right? So we know that that's a sub namespace, but it's system.file is the namespace. And so we are able to then have all of the file-related classes and extension methods and pieces like that all contained together, and I can put them all inside a single assembly if I want to. In this case, they do. So I would have a namespace that would be when I'm creating, say, a Windows 8 application, I'll have view models inside my XAML application. And often, I'll have a view model namespace. Not only is it nice to have them all contained that way, but it's an easy way to find them too. Whenever you're looking for something that does file I/O, it's neat to be able to go system.file, right, or system.io.file, and be able to see all of it there. And so it's not. I mean, eventually, a large application is going to have a lot of code, a lot of methods, a lot of classes, a lot of things you can interact with. This is an easy way to find them, and a nice way to kind of keep your code clean. It really is more about just discoverability and cleanliness of your code than anything else.
So we also mentioned that you can spread your namespace across multiple assemblies. Give me an example of why would we want to do that? Why would you want to split up what? By giving it the same namespace, you're kind of implying that these things should be grouped together. So why would we have different assemblies?
Well, that's a great point. I may have a foundational namespace that goes across my entire company. And so then I would have, let's say I work for Acme. Let's say I work for Microsoft. I would say Microsoft.
You do work for Microsoft.
Yeah. Are you a company shill like I am?
No. Well, I am for my company.
Ah, very nice.
Exactly. Crank to 11.
Right. Yeah. Oh, don't mind if I mention it now. All right. Yeah, so I might have, a namespace that refers to my company. It's often common for your company to be the first namespace in a longer one. And, dot my application, but my application breaks into different pieces. There's a web component that sits on all the services where I have WCF services, let's say. I also have a WPF client as well, and then I also have a Windows 8 client and a Windows Phone client. They really do all share similar namespaces, but I've broken them into separate assemblies because they actually don't belong to each other. When I write code specifically for WCF or WPF, either one, I'm not going to share between them the exact same, the UI logic on the service or the service logic or database logic on the UI, but they will maintain that same namespace for the continuity of it as well. So what will happen is I'll still be able to say company dot application dot, and then be able to drill into whatever's local and referenced inside that project. So it allows me to keep some sanity around a lot of code and still be able to have a consistent way of interacting with it, but not necessarily have all of it in one place, and because it just doesn't belong there. The stuff I do on the phone doesn't belong on the server.
Yeah. I mean, there's another advantage as well. Say, for example, you're writing unit tests, which I hope everybody is. You could create a subnamespace which contains all your unit tests. You have them as part of your application itself in your development environment where you're running your unit tests all the time, but you may elect not to ship the DLL, the assembly that contains those unit tests.
Yeah, so you would take your unit tests and extract them out to their own assembly.
Correct.
Yeah, absolutely. Yeah, you wouldn't want to ship your unit tests.
I've seen some that do.
Yeah, I've seen a lot of things.
Actually, part of your installation validation, you could run your unit tests in it, for example.
Yeah.
It's pretty cool.
That's an interesting idea, actually. I hate it.
It's only because it's a good idea.
Yeah, I hate everything good. That's the truth. All right. And then, so there certainly is a difference, but it's easy to misunderstand. And you could actually wonder, you're in system looking for something that doesn't exist. You have a reference to that namespace. You would think it's all there, but it's not. You can actually expand the namespace as you reference more assemblies.
One of the interesting things is, we were talking about encryption, and we were talking about hashing, and we were talking about signing. If we've got these assemblies that are being shared publicly, and they are supposed to do something, how do we trust that we've got something that is actually going to do what we purchased it to do? How do we know that somebody hasn't put some nefarious code and shipped it out as the same assembly name?
Well, that's a great point, and it is a dangerous situation if you think about it. I could be buying a suite of components from somebody to make my application look really cool. I get it, but I'm downloading it, from some nefarious operator, and I get it. It looks just like it, but little do I know it's actually a backdoor into my application. Yeah, that is a dangerous piece. How do we solve it? It goes back to kind of what we were talking about with encryption. Explain it to us a little bit.
So basically, you can have an assembly, and you can mark that it should be strong named. So strong naming will allow you to go in and specify a particular private key that will be used during the compilation process. The Visual Studio and the compilation environment would inject into that assembly a signature. and that signature could only be produced via the key that you have available. If you've purchased this key from a trusted source, then you are digitally signing that assembly with your identifier, so that a consumer can verify that this assembly has originated from you. It is also a prerequisite that assemblies have to be digitally signed before you can install them into the global assembly cache. What's that?
And we say strongly named, we're basically saying signed.
Exactly. We're basically saying that we have incorporated into this a contract that expressly guarantees that this assembly is from whom we say it is.
Yeah, and so GAC, what you were talking about before, the Global Assembly Cache. So we all have it. The Global Assembly Cache is in the Windows folder. It is where reused assemblies go, and they're at a global scope. They're then usable by anything that's installed. Very, very similar to registering a DLL back in the COM days. What's special about it is different versions of these assemblies can sit side by side. And so once they're side by side, it means I'm no longer version dependent. I can use whichever one that I need to, and it kind of removes that, I don't know, DLL hell that they always talked about, where some program would need to update to get the latest version so they could have its functionality. Meanwhile, other applications which relied on those older features or relied on things not to be the way they were in the newer versions get broken. So the GAC solves that by allowing them to be side by side, but the main purpose of the GAC is really to create a globally referenced set of assemblies.
Okay, so fundamentally we can put a using statement at the top of our source files, and we should be able to access them without having to worry about making sure they've been installed for our specific application.
Yeah, that's right. Now there's certainly, it will not be in the GAC if you haven't put it there, right? There are some that just ship with Windows, and you have quite a few, all the system ones, of course. But if you have one and you want to put it so that it can be reused across all the different applications you're releasing, say for your enterprise, it's your responsibility to put it in the GAC. You can use GPO to do that too, of course, and it will.
Is that group policy?
That is group policy. It can put that into it for all you don't have to go from machine to machine.
Okay, so that's kind of an IT administration activity?
It is. Okay. I hate to talk about that sort of thing.
Exactly. Go wash your mouth out.
Yeah, but nonetheless, once it's in the GAC, then we can reference it globally. And the benefit of having it like that is not just reuse, but it also allows the deployment of my application to the different desktops to be much smaller. I don't have to always include every reference to assembly.
Okay, and also when you purchase, say, vendor toolkits, their installer may well install their assemblies into the GAC for you, so you don't have to worry about doing that.
It's true, and it's a common accident that developers will ship thinking that it's in everybody's GAC when it is really only in theirs.
Which is kind of scary.
Yeah.
Same for source code control.
I've never done that, but I have heard of developers making that mistake.
Yeah. Nobody this side of the camera has ever made that sort of mistake.
We have a session later, on debugging. It was really, I had to learn a lot.
Yeah. Yeah, I've never opened debugger. It just runs first time.
What do you do with that?
Why would you need it? Okay.
Yeah. All right, so now back to sharing assemblies.
Exactly.
I mean, this is the real point, is I'll create an assembly. You can't get away from an assembly. One project is an assembly, and so you can't have a project without one. But the reason I would create multiple is probably for sharing and reuse, right? Being able to hand across. If I were inside the same .NET framework, then I don't really have to worry. I can create a library, a code library, class library, and I can share to my heart's content. And an individual assembly can have other assembly dependencies, and they all ship together. You can't just bring one over and doesn't wrap all the assemblies.
Because there is actually a disadvantage to using lots and lots of assemblies, because they all have to be loaded when you start your application, especially if you've got hard and fast references that need those things during startup. And so there are actually many patterns of application development whereby you actually have dynamically loaded modules that are done during runtime.
Yeah, that's powerful. And and the opposite is a good practice for developers too, where after they're finished with their application, to start looking at the references inside their project and removing them so that they don't have that extra memory burden.
Exactly.
It's costly in memory and boot time or startup time for their application.
Yeah. So one of the scenarios is, we create these, say, class libraries, which share these shareable components, and I built stuff in WPF, and I'm referencing all these WPF capabilities, and I've got all this logic, and all of a sudden, I'm building something, say, for the App Store, and I've got all this logic, and I can't reference this assembly.
They're totally unrelated, aren't they? They're incompatible with each other.
Yeah.
And
Why
so
is that?
Well, partly because they're built on different frameworks. And so when I write something for the desktop, I'm using the .NET framework. When I'm writing something, say, for the phone, I'm using the framework for the phone. And when I'm writing something, let's say, for Windows Store apps, like you were alluding to, I would be using WinRT. All of those are very similar, and they give developers a similar experience, but they certainly are different technologies in reality. And so as I build one for one for another, they are incompatible with each other, but we've solved the problem.
Oh.
Solved the problem with portable class libraries. So
that's well named.
It is, because it's portable, and
they are
class libraries. Yeah, it's all fantastic. And a portable class library, often the shorthand is just PCLs. So you'll create a PCL, and what it allows you to do is it feels just like a class library, by the way, and interacts just like a class library, but it generates a common denominator. So, for example, let's say you're writing an application for Xbox, you're writing an application for the phone, and you're writing an application for the desktop. Now, for the desktop, you have everything, because that's the big mama. But all these others have their own limitations.
Is that a technical term?
It is. It's on page 42.
Okay, awesome.
And anyway, so the reality is lots of the functionality that's on the desktop is not in the Xbox, right? And so as a result, because it's a portable class library, you can only include technology that is true for both. And so now, regardless of the fact that it's supported on the desktop, the portable class library removes capabilities inside the PCL.
So I can specify what platforms I want to target on that portable class library?
Yep, that's exactly right. When I create a new one, it lists all the platforms, and I select the ones I want.
Excellent.
Every one I select reduces more functionality, right? It can get pretty
Potentially.
brutal. Yeah.
Potentially.
Yeah, I mean, for example, reference to directory services, right, is not available when I'm on the phone. References to other subsystems like that are often not available when I'm on Xbox or when I go to a web client or something like that.
Okay, so some couple of best practices to think about then for using these portable class libraries. They should be focused mainly on behavior, functionality, and so on, and not necessarily system-level interactions. There could be data shapes, my data objects, my business rules applying to those data objects. They may perhaps define contracts that interact with systems, and we can use things like dependency injection and so on and so forth to abstract out the implementation of those services.
Right.
But it's more of a concept.
Yeah, there's a pattern interface design, and that's an important pattern when you use PCLs, because often, now here's an example of I could build a console application, and I have a PCL for it, and I create a service reference out to a web server. That's really handy, but now I've included the capability of, say, Windows Phone 8. Windows Phone 8 doesn't have that capability. So now in order for me to still be able to interact with it, now I have to handle, instead, an interface, allowing each of the systems that consumes it to pass a reference to it using just the interface. So these kind of design patterns are just things you can't get away from when you're using a PCL, because as you start making it a lower common denominator, you're going to have to work around that so you don't lose all the functionality, and there's no reason to share code in the first place.
Absolutely.
Yeah.
Great guidance.
Thanks. Now, Windows 8 is a little bit different, and it's not really a portable class library. It is a class library for sure, but it's specific to Windows 8 store applications, and those are WinMDs, or Windows Component Libraries, right? WinMD is the Windows metadata. It's really describing everything that's inside this library. And so I would create a WinMD not because I want to share with other platforms. I would create a WinMD because the logic that I have inside my library should be shared with other languages. So, I mean, there's a whole mess of snakes here, but the reality is this: if you're writing a Windows 8 application, you have choices as far as languages that you use, just like if you're writing a desktop application, you have choices as far as languages that you use. And in the case of Windows 8, I could write it in C++, C++CX, or I could write it in a .NET language like VB or C#, but I could also choose JavaScript. All three of those, and we want to give support in parity all of those different languages, and the way that's accomplished is through a Windows component library, which basically takes your code down to a lower level that can be, and we use the word projected, into all the other languages. So I can write something in C# that I can take down to a Windows component level that can be projected up into a JavaScript application and used in complete parity. It can also be projected up into C#. I could also, or into C++. I could also go the other way. I could say I could write it in C++, which is a common scenario. You know, like game developers may have a lot of their game logic in C++. So they bring all that logic down into a Windows component, which is actually quite rich and capable. And then they can expose it to JavaScript developers. A lot of power there.
So it's very similar to the value of the unified type system and the ability to write something in C# and share with VB in the managed world, but it's a different infrastructure that is tailored to support the Windows App Store environment.
That is a great way to say it. It is a different infrastructure tailored just for the Windows App Store, and they are foundational types rather than common types. But same concept all the way around. And the point is, foundational types can be translated into the consuming technology. So you may whatever types you interact with in C++, when they are projected up into C#, they're .NET types like I would expect. And when I interact with it with JavaScript, those are I interact with types that I would expect in JavaScript as well. So those are WinMDs. In fact, I have a little walkthrough here. I want to do that. Let me pull up my Visual Studio here, and you know what? Let me start from scratch. It's kind of fun to do that sometimes. Okay. And I'll start a Windows 8 app.
Can we see his?
And so that's the whole demo. What'd you guys think? No, just kidding. That was for you, Barry. All right. All right, so I'm going to create a new application.
The power.
I'm going to create a new application here, but it's going to be, I want to demonstrate WinMD specifically. So here we go. So I'll create a XAML application. And so a simple XAML application using C#, I'll go in and I'll start building out an easy UI. And so let me just do that real quickly. I'll say, I'll use a tool, I'll just build it out with the designer. And let me see, how about a toolbox, or text box, there we go. Text box, and maybe another text box here. I'm gonna add a quick, text block, so I can just have some simple text here, and then a button. So this is cool. The entire designer for Windows 8 development matches the experience that you would have in Blend because it's the same code base for the designer. It's really rich and nice. I'll add a button here, or a button I mean. There we go. It's something to cause the action to happen, and then we'll have some sort of result right there. Very nice. And so let me give everything a quick name so that I can talk to it. This will be, and we'll make it real. This will be T1. This will be T2. These are terrible names, by the way, Darren. And T3. Terrible name. Not a best practice. Not what I was intending to show there. All right. So let's make this in fact, let me make.
You're a dev designer, aren't you? I can tell just from that UI.
I'm an awesome dev designer. Are you kidding me? Nice indeed. All right. So there we are. There's the plus. This is going to be an addition application. So I'll go in here. I'll say let's default it to 1 and 2. Well, that's not 2. And then this will be where the result goes. We'll make this 3. All right, so it's just simple enough. I just wanted everything to have some default data. Here's the button. The button obviously should not say button. It should say equals or calculate or something like that. And let's see. I'll also make it nice and big as well. Let's see. That's probably too big. There we go. All right, good enough. I'll have a handler then for this, and I'll say when it's actually clicking, I want it to process the two values, and I want it to add them together. Now, I know that that logic is too sophisticated for me to allow it to be rewritten over and over again. So instead, I'm going to add another project here, and I'll say add new project, and I'll go again to Windows Store inside C#, but I'll take instead the Windows Runtime component, and this Windows Runtime component, here we are, is going to have class 1, and I'll just leave its name for now, and I'm going to create a static method. That's just so I don't have to new it up every time. And I will create a static method called sum them up, all right, just like so. And it's going to take in two values. And boy, I've got all kinds of problems because I'm doing a terrible job. There we go. All right, it'll pass in value 1, and it'll also accept value 2. Now, I know in all reality this is simple logic, but just imagine that there is a computational piece here, and it is the sort of thing you don't want all of your logic to be repeated, tested twice. Instead, you want to reuse it. And so now I'll just return v1 plus v2. Simple enough? So far, so good?
So far, so good. Is there any restrictions on what we can return back?
Yeah, there really are. Now, there are fewer restrictions, of course, when you create a class library, but because this is a Windows component and it's going to be brought down and shared, there are several rules to make sure it doesn't become incompatible with the other languages. One of them is that we can't use generics. We don't want to expose generics or require generics to be passed in, because not all languages support generics. We can certainly use generics inside the implementation. We just can't have that as some of the exposed pieces.
So we also wouldn't want to try and return like an anonymous type or anything along those lines.
Right. Anything that is specific to one language is something that you shouldn't do. Also, when I create a class, all of its members need to be public. There actually are several rules that we go through. I mean, probably about 6, right? 6 rules that we go through to make sure that you don't write a Windows component that is invalid. The nice thing here, though, is the compiler's on your side again.
Okay.
Right.
Compiler's awesome.
You are not going to be able to write a component that is incompatible and build it. You can write it, but you won't be able to build it. All right.
Okay,
so here,
awesome.
this is my reused logic. Let me kind of nuke some of the stuff that's here so we can have. I don't like having too much so it looks like it's real complex when it's not. All right. So here's the button 1 handler. This is my project, app 1. I'm going to add a reference, and then when I do, I'll add only from this solution. And I can see here's my Windows runtime component. It's called Windows Runtime Component 1. Again, an excellent naming convention. This is what I would recommend for everyone.
Your muse has not yet deserted you, that's for sure.
Yes, yes. It's wow, that's great. All right, so here now you can see all the references sit side by side, and they're all indicated specifically on what types they are. The little boxes next to them show me that it's a Windows runtime component. If I were to add a class library specific to C#, it would look it has a little box with the C# next to it.
Would that be an icon of some form?
Yeah, it has an icon.
Yeah.
There's no color to confuse you.
Yeah, it's awesome.
We got rid of all the confusing colors in Visual Studio, so that's one of the best parts. All right, so now I can reference it directly. So if I say Windows runtime component 1, this is me referencing, or me making a referral, I suppose, to what I referenced in my application. And I can say dot, and I can see there's that class 1, and I don't have to invoke it because I made it static. So I can say dot again, and there's sum them up. It expects 2 things to come into it, two different values. So let me go ahead and get those from the text. Let's see, it was t1.text.
Okay, whilst you're typing that, we had a question that came in that talked about does the compiler remove unused references at the top? So one thing to bear in mind is those usings are just shorthand so that you don't have to type the full namespace. It is not that is not what includes your references. If you could flick out to your references on your solution there for a second.
Yeah, let me jump up.
So here we have a long list of namespaces that we've imported so that when we start typing a type, this is where the compiler checks to see if they've been implemented. If you look over into your references inside solution, this is where you can add references to external assemblies and bring them in.
If I add a reference to for an external assembly and never use it, it's still there even when I build.
It's still there. It's still placed as a dependency for when this component is started up. So the compiler doesn't take into account and roll all the way through your code to say don't use these references. There are actually third-party plugins such as ReSharper and some other tools that can do that for you and remove unused references, but that's not something that's baked in. Great question, thank you.
So here's the implementation, just 3 quick lines. I needed to parse the text to turn it into the right type of a double. And so I have my double and my 2 doubles. I pass them in to sum them up. It returns it. I just convert it quickly to a string so that I can set it.
You're passing T1 text to both of those? Is that what you wanted to do?
No, I actually mean T2. I appreciate that.
You're welcome. Because it would be nothing more embarrassing than having an add method that didn't add properly.
I could think of something more embarrassing. And so, and then I just set it in there. Now, so if I were to run it, and I'll go ahead and run it, the nice thing is that logic, and again, I recognize it's actually very simple logic, is right here, it's abstracted out into a reusable assembly. This is a special assembly that is not meant to be reused from app to app, but reused across languages, app to app, which is very special.
But you could use it app to app as well if you wanted to.
You could use it just like a class library. But unfortunately, not unfortunately, but just the reality is, you would still have to obey those rules, and you can't go break it for other languages, even if no other language actually works. So I'm going to hit debug and let it run on this local machine. Here's my beautiful UI that I put together. 1 plus 2 equals, and I'll blank this out so I can actually see that it runs, and then it comes back to 3.
Awesome.
Let me show you something. If I said 1 plus 2.1, that also works.
Ooh,
I just wanted to prove it wasn't
magic.
smoke and mirrors.
That's just magic.
Demos are never realistic.
What happens if you put Fred in there?
It would not parse, and it would.
And we would get an exception.
We would get an exception right where it tries to parse.
Paranoid. You did not protect yourself from some user.
It's because I know who the user is.
Exactly, and that's why you should have protected him.
He's trustworthy. He's trustworthy. He's my favorite user so far. He's the one who doesn't try all the edge cases. All right, so let me add another project. So here's a second project, but this time I'm not going to go to C# Windows Store. This time I'm going to go down to other languages, JavaScript Windows Store.
Goodness. I wonder if Palermo's still on. He's dancing a happy jig right now.
You know what? He's probably, yeah, that's right. Never has he seen me write a JavaScript app. But
I'm not entirely sure he's going to yet.
Oh, gosh, it's easy. It's easy not to like you very much. All right, so. All right, here's my UI. It's a simple little UI. I'm going to just throw it together really quickly because I don't want to do a bunch of HTML anything. That's just because I'm a XAML guy. You know what I mean? But the reality is, different applications need different technologies. Different development teams need different technology. That's just the way it goes. Yeah. For me, it's XAML today. So I'll create
there's a lot of value in being conversant across different languages and different environments and so on. You know, in general, as developers, we should strive to be competent across a number of different technologies because it really helps round out our experiences, and we can also understand where certain features come from. We mentioned earlier on that contracts came from Eiffel. There are a rich source of different languages out there that really complement your skill sets. So if you've only focused on one language, I really do recommend looking across a broader scheme. Yeah,
that's just good career advice.
Exactly.
Yeah. All right, so I'm going to give
This is just the course that keeps on giving.
Yeah, this has become like a self-help kind of course.
Exactly.
Yeah. If you find that the technology seems stale, just try another technology.
Exactly.
All right, so let's see. I want to give some default values as well. Equals 2, and then we'll do it down here. Instead of 3, which made it seem too easy, I'll set it to 0. All right, very good. I need a, let's see, I'll say on click. And then, you know what, obviously, if I were writing a true HTML application, I know that I would separate everything out, CSS classes, Java files, things like that. I'm not going to do that here because it's a demo.
Because it's a demo.
Right. And so let me, here we go. So let me call this in the on click here. Oops, on click equals do work. ORK. Everything look all right?
It looks pretty good to me.
Okay, just making sure. All right, so just like our previous project, these all act exactly the same. So I made a reference in app 1 over to my Windows Runtime Component 1. I'll need to do the same thing inside this one. Okay. So I'll go to its references. It's the same dialog. I go to the solution, and they're all listed here.
So wait, you're saying that this will be available in JavaScript?
Now, yes, I'm going to say this is going to be available in JavaScript. You read my mind, or the slides. And so we.
Well, there's something on the slides.
So what's beautiful now is this runtime component written in C# is about to be leveraged by a JavaScript application. So here I can say it'll be Windows runtime component 1. Class 1. This is the same experience as I was having over on C#.
So you've got IntelliSense as well.
That's right. The tooling around JavaScript for Windows 8 development really is rich. I mean, it really is. But I want to show you something interesting. Here's my sum them up. But look what's special about it. It can't.
Is that a different case?
Isn't that interesting? Yeah, the convention for a JavaScript is for the first letter in a method to be lowercase, and yes, in a method to be lowercase. But I didn't do it that way. If we were going to go back to it, you would see I would have followed standard C# notation instead. And so here I'll call sum them up. It's neat how this is all done by the projection. Again, I didn't write sum them up with a lowercase s. I actually created the metadata for it that was projected into JavaScript. It's very powerful.
So this is interesting. So we're in JavaScript and we're consuming something that's been implemented in, say, C#. And you've mentioned that we could do it in C++. Can JavaScript be used to produce a WinMD component that could be consumed by C#?
You cannot. So the only languages that can create WinMD files or Windows components are only the .NET languages or C++. If you try to create it in JavaScript, well, there's no way to do it.
Okay.
There's no option. Okay. In fact, I don't know if you remember that file new, when we went to JavaScript, there was one. Right, there was one option to choose from. Okay, so here we go. Now here I am. I'm calling it. I'm just breaking onto another line so it doesn't go too far over, and I'll set t3 dot value. So the value with the lowercase v. There we go. All right, so this is this logically is almost identical to the implementation of the of the logic that. What is this? Can you help me?
No. You're on your own, Jack.
The logic for the button click is almost identical to the logic that we've implemented for.
And what we can actually see there is a very common syntactic root. As we were talking about beforehand, how many of these languages are inspired from the same sort of foundational base. We can see there's very much the same syntax there. Well,
that's a great point, yeah, with open and closed little squirrely brackets. You're absolutely right. All right, so this will run the same way. I'm going to set app2 now to be my my startup project and go ahead and debug it. It'll deploy it out for me and run it. It's very similar looking. I didn't take any time to do anything fancy with it. 1 + 2 equals. Now when I click on the equals button, it'll execute inside the runtime component again, the exact same logic that I'd saved from before.
And there is 3.
And if I were to put a decimal or whatever, it all works the same.
That's amazing.
And just like you said before, if I was going to put Fred, it would fail. There's no reason for me to show a failure. Just trust me, it'll fail. Right, there you go.
Well, it's handled gracefully in JavaScript.
Yeah.
Because of the dynamic typing.
Yeah, you should see it in C#.
Exactly.
All right, so that is a WinMD. A WinMD is a Windows runtime component. It's what you can create specifically for Windows 8 app development. Okay, so that's how we share code across languages. Class libraries are how we share code across assemblies or different projects. And then portable class libraries are how we share code across platforms, right? We're not specific to Windows 8, but specific to really the Microsoft platform.
You meant more the .NET ecosystem.
Yeah. The .NET ecosystem is probably the best way to say it. Yeah, it doesn't go everywhere, but it certainly goes wherever fine .NET is sold.
Indeed.
No doubt. All right.
Okay, so let's moving on. We're going to touch on diagnostics and instrumentation right now.
Another important part of your application is
and I know one of your personal favorites.
It is. It really is. It's kind of like code contracts. If you're going to write an application, you need to be able to make sure that it's a good experience for the user. One way to do that is to design the UI, but another way to do it is to make sure that it performs properly. And now, being able to determine if your application is performing properly is difficult. It's very difficult. Odds are the developer that is creating it has a monster machine that is awesome, and it could load on almost any your application on almost any other device, and it's going to be less powerful than the developers. I mean, that's kind of a universal
Well, why
truth.
don't we just tell the users to upgrade?
Yeah, just get some more RAM, get some more...
Exactly.
Yeah, but in case that doesn't happen, we can do some profiling and analysis on your application for performance. How do we do that? Well, let's talk about some of the terminology first because it's important. So it starts with instrumentation. Instrumentation is the part of the code that you include that stores performance information. So every time a method is run, you might want to have that as an instrumentation point where you log it, right? That's a possibility. Or perhaps when you call a database and it takes 10 seconds or it takes whatever seconds it is, you want to take that resulting number and let that be instrumentation points as well. And so the instrumentation is just the practice by the developer to go into their code so that they can go to these specific points where performance might be measured and be able to contain those points or be able to expose those points so they can be stored somewhere and analyzed.
So it's like web analytics, but for your code instead.
It's like web analytics, but for your code. That's a great way to say it. And it's effort. This isn't automatic. There are tools out there that will analyze your code, but the best way to add performance measurement to your code is for you to do it. You understand your code, not a generic analysis tool. Although those tools are very powerful.
Yeah, I mean they can certainly give you a lot of insight, but as you say, there's nothing better than intentionally introducing instrumentation into your application.
So you have instrumentation that takes these data points and puts them out somewhere. Wherever it puts them, that is your telemetry. That is the data that you can use for diagnostics. And then you perform analysis against that telemetry, not only to try and figure out why something went wrong, why something went slow or whatever, but also because you might be looking for trends. And telemetry can give a great example is Internet Explorer. We went from one version to another and the favorites button changed, or the favorites menu changed, right? And the location changed. It was a little harder to get to, and that's because of telemetry that showed us that people weren't using that method.
So you could bring something that was more popular to the forefront and move something that was to the background.
That's right. It's not just about finding bugs. It's not just about making it faster. It's making it better.
I mean, also, there's a lot of value in running instrumentation in a non-critical scenario because it allows you to establish a baseline so that you can then determine when you've deviated from that baseline.
That's right. If you think it's going slow, how do you know if you don't know how it runs when it's not slow?
Exactly.
Yeah, that's right. And creating that initial baseline, and you may have several baselines when you're all done, because you may have baselines based on device configuration. Right? That's a big deal.
Yep.
Okay, so let's talk specifically about performance counters. This is a Windows Windows capability, I guess is the best way to think of it. Performance counters are out there that you can leverage as a .NET developer. You can go and create new categories for counters, create new
So the .NET framework already has instrumentation baked into it?
It does, it does. And no, the Windows does. And then the exposure of performance counters is through the .NET framework. And so, and then of course probably the framework has instrumentation, by the way, of its own.
Yeah, like memory allocation and those kind of things, so you know what's going on there.
Yeah, but your app, it doesn't implement it for you, of course. It just allows you to easily kind of access the performance counter subsystem inside Windows. And so performance counters are really a discrete number, and they're a number that reflects the current state. So let's say it is how long it takes for a user to log in and this process of calling the database and encrypting their password, whatever it is, right? You're going to measure that time with a stopwatch or something so that you can determine how long it takes. You're going to write that out to a counter, and that counter is going to say how long it just took. It's not going to keep an eternal history of it, right? So if you do want that history and you do want trending, then you use tools, and they have tooling to be able to capture what the performance counters are and then pull those down into some sort of store. And so we use like Performance Monitor can do something like that.
It's a great tool.
Yeah, it's a tool that we've all used to analyze other people's code that is slow, because ours so far is not a big problem.
With our 3 lines of code?
We kill it, don't we?
Exactly. It's like you need to run code that runs this fast.
That's right.
So do you need any special privileges?
Yeah, I think that's important, is that you can't just write to it, right? You can't have somebody with no privileges on this machine to go creating categories, creating performance counters. No. You do have to have the right permission. Permissions change if you're just writing to it or reading from it, but certainly to go and create new ones, you have to do something.
Awesome.
Yeah, absolutely. Okay, so let's see. This is a presentation, or this is a snapshot of performance counter. It kind of shows the graph that you can get back. It's not necessarily real time, but it certainly can be real time.
My screen, Barry.
When you're done, guys.
Barry, my screen, please.
It's the other one.
That's it. Thank you.
So
it's all about us, guys. Come on.
No, it's about the students. Okay, yeah.
Stay on target.
Yeah, exactly. Working. Got it. Okay. So anyway, so this can show real time, reading it as you know, almost. It is actually connecting to it and treating it like a stream, because this sort of trace information is very voluminous. And so here I can pick the individual ones. This one is just the processor utilization, and you can start to see how it goes over time. But the code on the left shows how I can attach to it, and I can read from it, or in this case, I'm actually incrementing it. I can decrement it, of course, set it to an explicit value as well. The most common is to increment or decrement a count. There are raw values that are going to be important when you're coming to timing and things like that. Anyway, with this sort of data, once it's exposed, extremely, extremely valuable. What you do need to remember, though, as you write it out, it can be so voluminous that you start impacting the performance of your app by measuring the performance of your app, right?
Exactly.
Profiler for SQL Server is notorious for that, right? You go in and you're like, what do you want to, there's something is wrong with the performance of this query. What do you want to listen to? Everything. Now your query is so slower. Yeah, the tracing itself is the performance killer. So it is important to have all the instrumentation there, but it's also important to have some sort of mechanism or method that you can dial it down, and so that you don't have to have all of it being logged out. If nothing's going wrong, just leave it alone. And then, and so that's, again, that goes back to trace listeners, which we talked about before. And the trace listener can implement switches then that determine the kind of the state of the environment.
And the cool thing about traces is obviously it can be part of a released application, and you can change it through the application configuration to toggle how verbose it is, or whether it's on at all, yeah?
Yeah, you don't want to beat up a production user, but you do want to deliver this into production, because this is where problems happen. They never happen on your machine. They happen usually on the CEO's machine. That's kind of how it's. If
normally
CEO,
around
then
annual review time.
Yeah, exactly. Let me pull up your app for a second. What is this dialogue that says close? All right, very good. And then we also have event logs. I think it's worth at least pointing out that event logs are an excellent. You may not have like deep instrumentation inside your application, but you may have some. And you know, a user just logged in, an invoice was just submitted, something like that. And there's no reason to not just use the event log for that. It's a great place to put high-level major events inside your application. It's not really meant for performance measurement, but it's a great way to kind of debug scenarios so you can see what's going on.
And also capture diagnostic output. Say, if an error does occur, you don't want to necessarily present to the user the internal stack trace of what's going on. You're going to give them a user-friendly message, but you could drop out into the event log and write that stack trace.
So that really you do two things when an error occurs. You do say to the user, we're sorry, right?
You do.
But you don't give them a whole bunch of mess.
Yeah, don't scare them.
You give to Windows, or the event log specifically, everything, so that we can diagnose what's going on. You know, why did that happen to you?
Yeah.
Yeah. Just reboot is usually what we do.
Exactly.
That's the truth, isn't it? All right. So before we do anything, before we do this, let me pull up in Visual Studio here a project that has some performance issues. And let's look at some of the built-in diagnostic tools that we can use here that really not solve the problem, but just give us a mechanism to diagnose it, be able to find out what's going wrong.
Okay, whilst Jerry's bringing that one up, we just want to remind people to vote about the poll during the break. Reminder done.
Yeah, don't forget there's a poll. Don't forget, vote once, vote often. That doesn't work right. Vote early, vote often.
Get your demo going.
I don't know how vote often ever worked. All right, so here we are, diagnostic.
It worked often in Chicago, apparently.
All right, let's take a look at an interesting method that we have called run. And so run is a for loop. It goes from 0 to whatever it is I pass in. And then inside it is yet another for loop identical to it. And it goes from 0 to the number I pass in. And then it adds to a variable, an N64 here, whatever that number is.
I don't know, but that looks like it might be a bad idea.
This is all a bad idea.
Oh, okay.
This is we'll just call this
a best practice
performance simulator. No. Of course it's a best practice when you're simulating bad performance.
Ah, I see.
Yeah. I guess you'd simulate poor performance. Yeah, but that could be bad. All right, so here we are. Inside my app, or when the application runs, I call these 5 methods. So this one is sort of nestled down here so I don't have to see it. These are the ones I want to investigate. I have a method called run 1, 2, 3, 4, and 5. Each one executes a little bit longer or a little bit shorter of a loop that's going to go there.
Okay.
And this sort of loop is difficult to optimize. It's a great way to show just burdening a system, right? So another thing I could have done is while true. Yeah, we talked about that.
We never got anything come back.
Well, that's right. We do want it to end eventually, right? You can't diagnose eternity. You can, but it takes a while. So here we go. I'm going to write it out.
Result is infinity plus 1.
We know that it'll loop through, add these numbers together for us, and we'll write out the value. And the only reason we're writing out the value is so that I can see that it's finished, right? So we'll go through 5 iterations, and so let me go ahead and do that, and you'll see it takes just a couple seconds to really go through these. It takes, that one was quick, but this one's kind of hard. It's only getting harder now. And so if I had my processor, let's see if I can pull it up in time. I can't, I bet. Well, you can actually see it was peaked out, and then it dropped back down because the application just finished. Right?
Okay.
So I got to figure out what's killing my
thousands
CPU.
Wouldn't.
What's that?
We'll believe you, thousands wouldn't.
Yeah, thousands wouldn't. This is good, and so this happens. When a user is trying to self-diagnose an application, this is almost all they've got, and so they'll pull this up and they're like, "Golly, my CPU is peaked out. What's going on?" It's pretty neat. All right, so I'll go through the same scenario, but this time I'm going to select to use the performance profiler.
Okay.
And so this is built into Visual Studio, and what it does is it will run my application, perform all the tasks just like I would, and then it'll give me some feedback on what was actually going on. And because it's inside Visual Studio, when it does give me feedback, it won't say at this time it was this long. It can even tell me down to the method that was being called, down to the line that was being called.
Show me.
It's very powerful. Can I show you?
Sure.
All right, so it's under the Analyze. I want to make sure that everybody saw. Under the Analyze menu, I'll just select Launch Performance Wizard, and I'm going to just do implementation for now. This is the quickest way to kind of show this off. It's going to ask which inside this solution, we've got a lot, but the only one I really want to show is just this one I've set up for it, Diagnostics, after 26. I'll say Next, and here we go. I'm going to say Finish. It'll launch my application. Of course, it's a self-running application, so I don't have to interact with it. So it'll go ahead and launch it. It'll do the same process.
It's capturing all of the instrumentation outputs.
That's right.
Okay.
As well as all the common instrumentation like CPU utilization, memory utilization.
So this is an
like
example where observing it may actually change what's being observed.
It could. Yes, that's exactly right.
Cool.
Just because the analyzer is running, it might actually dial down its performance a little bit. Yeah, absolutely, it could. Okay, so there was a checkbox on the wizard that popped up the profiling report for me, and the profiling report shows me really interesting information. So along the bottom timeline here, it shows me in real time, real seconds, like wall clock time, they're saying. Here's the application that ran. It ran 13 seconds, and the line itself is showing CPU utilization during that time. And so this is good. It balanced out CPU utilization, but I want to be able to see, inside this period what is going on, or I want to be able to drill into individual methods down below. But what's also nice is it by default gives me all the hot paths. So the hot paths are those methods that take the longest, right? As far as time. And so here I can see run 3 takes the longest of all. And so if we were to look at what run 3 does, let me pull that little sample.
Can you just click on it and I'll take you to it?
Oh, yeah, it sure will. Thank you. Yeah. So if we were to look at run 3, that makes sense that it's the hottest on the hot path because it is 40,000 and everything else is a little bit lower.
Okay.
If we were to go back to that hot path and say, well, what's the next one after that? It had better be run 5, right? Because that's the next one down. I mean, that's the way that it's measuring it. So if we go back to it, we can see 3 and then 5, then 2 and then 4, and this is great. I'm seeing the application. Maybe I don't know yet what is really causing it, but it certainly gives me the place to start rather than just saying how much RAM do you have installed.
And so obviously this is a contrived demonstration scenario, but we would encourage everybody to run this on their existing applications just to get a good idea of what's going on. One of the key traps that we sometimes fall into as developers is this thing called premature optimization, which is we look at something and we go, oh, I think this is going to be a waste of time and it's going to churn for too long and so on. The reality is this thing that we love so much, the compiler, is actually incredibly smart and will do an awful lot of optimization for you. It will look at an inefficient set of syntax, and behind the scenes, when it emits the intermediate layer, the output of this compilation, it will actually do some optimization. So don't presume that something that you see is going to be the slow. Prove it by using the profiler and do the analysis, and then only spend your valuable time and energy rectifying problems or performance hiccups that are actually identified by the tooling instead.
This tooling is great because it's built into Visual Studio. We talked about before, there's third parties out there that do probably quite a bit more, right? But this is a great starting point, and it almost takes away the excuse for developers. You know, we don't have the you do have the tooling. It's right here inside Visual Studio, and it makes your application that much better by adding diagnostics around it. I could also include now custom performance counters that I'm incrementing as well, right? I want to see, you know, how many people are logging in at once and different pieces like that.
Exactly. So really do an analysis of your domain. The other point I want to point out is make sure that you do this profile analysis in the release build, the build that's going to go out to production, because when you change your build configurations in Visual Studio, it enables optimization, which will actually change the execution path of the code behind the scenes. So you actually want to be measuring performance on those, on the true environment, rather than spending a lot of time and effort trying to optimize your debug build. Again.
Not every version of Visual Studio is going to include all of this advanced tooling, right? I'm using Ultimate right now, and you're going to need Ultimate, and I think Professional will include all of the diagnostics tools that we've shown tonight, or today, or whatever time it is.
Correct. You won't get this in the Express Edition.
It certainly will not get it in the Express Edition, also known as the free edition of Visual Studio.
Absolutely.
There's a free version of Visual Studio for every technology that we have.
Sure.
Very good. So, you can control the cost of performance counters by perhaps you could just you could write to them less frequently. You certainly don't want to do it too much. The way that you measure inside your application, you need to think about that. Make sure that's not too costly as well. You want to add this instrumentation so that you can make your app better. But the core takeaway is, don't add so much instrumentation that you have now made your application perform poorly because of it.
Sure.
Absolutely.
So let's do a quick recap.
Okay.
So at the outset, we talked about splitting up assemblies and their assemblies' relationship to projects. We also talked about sharing assemblies, be they through the portable class library for across platforms, or by leveraging WinMD components for sharing across languages. We also just did a deep dive into diagnostic capabilities and explored the value that the performance profiling toolkit can provide in the Ultimate and Professional editions.
That's right. One more reminder to all of our audience here is that the code that we're using and many of the examples that we aren't showing are all in a solution that we made available to you. It's at xaml.codeplex.com. You can find the Microsoft Virtual Academy link there. Download the solution, follow along with us, or go through at your own pace to learn things that we may have skipped because we just don't have time today.
Great. And please remember, please vote.
Please remember, please vote. Absolutely right. All right, we're going to take a 10-minute break. We'll see everybody soon. Goodbye.